Good day, everyone. Today, I will give a short overview of my project. So, the project has been undertaken under Professor Vaibhav Kadeva from ISC Bangalore, and I have received. I would like to thank CNI for funding this project. So, let's move on. So my topic of my project is designing rate control and scheduling protocol for a wireless network control system. So, let us see what is a network control system. So, in a typical control system, we have a plant, a controller, and sensor and actuator. So, and all these components have to communicate with one another in order to keep the system stable at the plant. And suppose in the figure which I have shown, the communication has to be between the sensor and the controller, and from the controller to the actuator. So the estimates have from the sensor need to be communicated to the controller and then back to the actuator. And the network which is being shared by all the plants introduces random delays, data loss, and data corruption. While there are adjusting on while there are protocols available for networks such as TCP is not really suited for this type of application because it doesn't take into account that each source requires a different transmission probability, and there is a certain minimum transmission rate which has to be achieved in order to keep the process stable at the plant. So this is the problem setup which we have considered, in which we model the wireless network as a directed graph with some nodes and links, and each of these links have varying capacity in order to model some fading. And we consider a set of sources and destinations with each source having corresponding destination. And we are also given the route or the set of links which have to be activated in order for the packet from the source S to reach the destination D. And the transmissions at the sources are stochastic in nature. That is, that each of them transmit with certain probability PSK at time slot K. And in order to model interference, we consider a primary interference model, in which the interference is resolved through time multiplex schedules. Each schedule has a certain rate pi I of being selected and at any time slot K. And the queues at each of the nodes in the network are kept bounded or stable by using the standard red protocol. So the red protocol as does what it does is that as the queues size increases at a node, the linked drop probability increases. That is, the incoming packets have a higher chance of being dropped as the queue size increases at that node. And the objective of ours will be to reduce the estimation error between the source and the destination. That is, we want to reduce the error between the destination estimate or the estimate at the controller side and the true value at the source side. So this is the solution which we get after formulating the problem and finding the solution. So this is how the source rates evolve, the PSKs, and these are how the pi i's evolve. And these are the prices in order to keep the sum of pi is equal to 1. PS don't have such constraint. So we can see that the PS depends on the AS max, which is the how fast the process is evolving, and the DL case, which sort of mention the link drop probabilities, which are decided by the standard red protocol. So the congestion is very high, thus the DLs will be high. And so these DLs sort of serve as a feedback to the rate controller and the scheduler to adjust their probabilities. And then we have the optimization parameters, NS, KS prime, K pi prime, and K mu, which can be adjusted to modify performance. And this is the sort of result which we obtain using this protocol. So if we consider the network on the left side, with 3 sources and 3 destinations. We see that this is the solution which we get. In this solution, which first thing to note is that the S1 process is evolving very slowly, right, while S2 and S3 evolve pretty fast. So the rate of transmission of S2 and S3 is higher than the rate of transmission of S1. And the scheduling rate was also, you can see, go to different values and reach steady state after a certain amount of time. And these scheduling rates is also decided by these source rates and how the process is evolving. So, and we can see that the estimation error becomes bounded after a certain amount of time. Thank you.